A split bolt connector can indeed be used to connect more than two wires. However, it's crucial to understand the limitations and best practices to ensure a safe and reliable electrical connection. Split bolt connectors are primarily designed for copper-to-copper connections, although some are dual-rated for both copper and aluminum. When connecting multiple wires, the primary concern is maintaining adequate contact surface area between all conductors. This is to prevent overheating and potential electrical failures. The number of wires that can be safely connected within a split bolt depends on several factors. Firstly, the size of the wires themselves. Secondly, the size of the split bolt connector. And thirdly, the specific manufacturer's recommendations. Generally, smaller gauge wires allow for more conductors under a single split bolt compared to larger gauge wires. It's important to ensure that all wires are securely clamped within the connector, providing a tight and consistent electrical connection. The use of antioxidant compounds is highly recommended, especially when connecting dissimilar metals like copper and aluminum, or when the connection is exposed to moisture or corrosive environments. These compounds help to prevent oxidation and corrosion, which can increase resistance and lead to overheating. When installing multiple wires in a split bolt, it's best practice to arrange the conductors in a parallel configuration, ensuring that each wire has direct contact with the split bolt's inner surface. Avoid twisting the wires together before inserting them into the connector, as this can reduce the contact area and create uneven pressure. After tightening the split bolt, it's essential to properly insulate the connection with electrical tape or insulating boots. This will protect the connection from moisture, dirt, and accidental contact with other conductive surfaces. The National Electrical Code, or NEC, provides guidelines for making electrical connections, including the use of split bolt connectors. Always refer to the latest edition of the NEC and local electrical codes to ensure compliance. While split bolt connectors can accommodate multiple wires, it's often more practical and reliable to use alternative methods for connecting numerous conductors, such as terminal blocks, wire nuts, or crimp connectors. These alternatives offer better organization, improved insulation, and easier maintenance. Before making any electrical connection, always energize the circuit to prevent electrical shock. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electrical wiring, it's best to consult a qualified electrician. Improper electrical connections can be dangerous and may result in fire or electrical shock. Consider the ampacity of the wires being connected and ensure that the split bolt connector is rated for the appropriate current. Overloading the connector can lead to overheating and failure. Inspect the split bolt connector for any signs of damage or corrosion before use. Damaged connectors should be replaced immediately. When tightening the split bolts, use a wrench that is properly sized for the connector. Over-tightening can damage the connector or the wires, while under-tightening can result in a loose connection. After making the connection, test it with a multimeter to ensure that there is good continuity between all conductors. A high resistance reading indicates a poor connection that needs to be addressed. When working with aluminum conductors, use a split bolt connector that is specifically designed for aluminum or dual-rated for copper and aluminum. Aluminum expands and contracts more than copper with temperature changes, which can lead to loose connections if the wrong type of connector is used. Consider the environment in which the connection will be located. In damp or corrosive environments, use a split bolt connector that is made of corrosion-resistant materials, such as tin-plated copper. Always follow the manufacturer's instructions for installing split bolt connectors. These instructions provide specific guidance on wire preparation, tightening torque, and insulation requirements. When connecting different sizes of wires, choose a split bolt connector that is sized appropriately for the largest wire. You may need to use reducing bushings or adapters to ensure a secure connection for the smaller wires. Avoid using split bolt connectors in locations where they will be subjected to excessive vibration or mechanical stress. These conditions can cause the connection to loosen over time. Regularly inspect split bolt connections for signs of corrosion, overheating, or looseness. If any problems are detected, repair or replace the connection immediately. When replacing a split bolt connector, choose a connector that is the same size and type as the original. Using an undersized or incompatible connector can compromise the safety and reliability of the connection. Consider the accessibility of the connection for future maintenance and repairs. Avoid installing split bolt connectors in locations that are difficult to reach or inspect. When making multiple connections in a single junction box, organize the wires neatly and secure them with cable ties or other supports. This will help to prevent accidental contact between conductors and make it easier to troubleshoot any problems. Always use electrical tape that is rated for the voltage and temperature of the application. Inferior tape can fail over time, exposing the connection to moisture and other contaminants. When insulating split bolt connections, overlap the tape layers generously to provide a complete and waterproof seal. Extend the tape beyond the edges of the connector to protect the wires from abrasion. Consider using heat shrink tubing instead of electrical tape for insulating split bolt connections. Heat shrink tubing provides a more durable and professional-looking insulation. Before applying heat shrink tubing, make sure that the connection is clean and dry. Use a heat gun to shrink the tubing evenly around the connection, avoiding overheating. When working with stranded wires, make sure that all of the strands are properly inserted into the split bolt connector. Loose strands can create a high resistance connection and lead to overheating. Consider using a wire ferrule to consolidate the strands of stranded wires before inserting them into the split bolt connector. Wire ferrules provide a more secure and reliable connection. When connecting solid wires, avoid nicking or damaging the insulation. Nicks in the insulation can create weak spots that are susceptible to moisture and corrosion. Use a wire stripper that is properly sized for the wire gauge to avoid damaging the insulation. When connecting wires in a split bolt connector, make sure that the insulation is stripped back far enough to allow for a proper connection, but not so far that bare wire is exposed outside of a connector. Consider using a wire gauge tool to accurately measure the wire size before selecting a split bolt connector. Using the wrong size connector can compromise the safety and reliability of the connection. When connecting wires with different insulation types, make sure that the split bolt connector is compatible with both insulation types. Some connectors are designed for specific insulation types, such as thermoplastic or thermoset. Consider the ambient temperature in which the connection will be located. High temperatures can increase the resistance of the connection and reduce its current carrying capacity. Use a split bolt connector that is rated for the appropriate temperature range. When connecting wires in a damp or corrosive environment, consider using a waterproof or corrosion-resistant split bolt connector. These connectors are designed to protect the connection from moisture and other contaminants. Always follow the instructions provided with the split bolt connector regarding tightening torque. Using too much or too little torque can damage the connector or the wires. Consider using a torque wrench to ensure that the split bolt connector is tightened to the correct torque. When connecting wires in a critical application such as a life safety system, consider using a redundant connection method. This involves using 2 or more split bolt connectors to connect the same wires, providing a backup in case one of the connections fails. Regularly inspect split bolt connections for signs of overheating, such as discoloration or melting of the insulation. If any signs of overheating are detected, replace the connection immediately. Consider using a thermal imaging camera to inspect split bolt connections for hotspots. Hotspots indicate areas of high resistance that may lead to overheating and failure. When connecting wires in a hazardous location, such as an area with flammable gases or vapors, use a split bolt connector that is rated for use in hazardous locations. These connectors are designed to prevent sparks or arcs that could ignite the flammable materials. Always consult with a qualified electrician or electrical engineer before making any electrical connections in a hazardous location. Consider the potential for electromagnetic interference, or EMI, when connecting wires with split bolt connectors. Split bolt connectors can act as antennas radiating or receiving EMI. Use shielded split bolt connectors or other EMI mitigation techniques to reduce the risk of interference. When connecting wires in a sensitive electronic circuit, consider using a solderless connector instead of a split bolt connector. Subtlest connectors provide a more reliable and low resistance connection. Always use a wire brush to clean the wires before inserting them into the split bolt connector. This will remove any dirt, corrosion, or oxidation that could interfere with the connection. Consider using a wire antioxidant compound to prevent corrosion and oxidation of the wires in the split bolt connector. Wire antioxidant compounds help to maintain a low resistance connection over time. When connecting wires with different stranding configurations, such as solid and stranded wires, use a split bolt connector that is designed for mixed stranding types. These connectors provide a more secure and reliable connection between different stranding configurations. Consider using a pre-insulated split bolt connector to simplify the insulation process. Pre-insulated connectors come with a layer of insulation already applied, saving time and effort. When connecting wires in a high vibration environment, use a split bolt connector with a locking mechanism. Locking mechanisms help to prevent the connector from loosening due to vibration. Consider using a split bolt connector with a visual indicator to show that the connection is properly tightened. Visual indicators provide a quick and easy way to verify the integrity of the connection. When connecting wires in a direct burial application, use a split bolt connector that is rated for direct burial. Direct burial connectors are designed to withstand the harsh conditions of underground environments. Always follow the manufacturer's instructions for installing direct burial split bolt connectors. When connecting wires in a submersible application, use a split bolt connector that is rated for submersible use. Submersible connectors are designed to prevent water from entering the connection. Always follow the manufacturer's instructions for installing submersible split bolt connectors. Consider using a split bolt connector with a built-in strain relief mechanism. Strain relief mechanisms help to prevent the wires from being pulled out of the connector. When connecting wires in a high voltage application, use a split bolt connector that is rated for the appropriate voltage. High voltage connectors are designed to prevent arcing and insulation breakdown. Always consult with a qualified electrician or electrical engineer before making any high voltage connections. Consider using a split bolt connector with a removable cover for easy access and inspection. Removable covers allow you to quickly inspect the connection without having to disconnect the wires. When connecting wires in a confined space, use a split bolt connector with a compact design. Compact connectors are easier to install in tight spaces. Always use a wire marker to identify the wires before disconnecting them from a split bolt connector. Wire markers help to prevent confusion when reconnecting the wires. Consider using a split bolt connector with a reusable design. Reusable connectors can be disconnected and reconnected multiple times without damaging the wires or the connector. When connecting wires in a temporary application, use a split bolt connector with a quick disconnect feature. Quick disconnect connectors allow you to quickly disconnect and reconnect the wires as needed. Consider using a split bolt connector with a color-coded design to simplify the wiring process. Color-coded connectors make it easier to identify the correct wires to connect. When connecting wires in a renewable energy system such as a solar or wind power system, use a split bolt connector that is specifically designed for renewable energy applications. Renewable energy connectors are designed to withstand the harsh conditions of these systems. Always consult with a qualified electrician or electrical engineer before making any electrical connections in a renewable energy system. Remember that while connecting multiple wires with a split bolt is possible, it's crucial to adhere to safety standards and best practices. Always prioritize safety and consult with a qualified electrician if you have any doubts.